Alright, today I'm going to be talking about this actuator that I made from a DOF motor and the supplied SFU gearbox. So I did a quick video of this on Facebook, just of it working. But basically, as this motor turns, the actuator comes in, goes the other way, the actuator gets pushed out, and under this cover there's a sensor. This is all 3D printed. And here is the mount for it right here. So you can see right now it rotates, but there's holes along here that you can put bolts in, and then it'll clamp it down and it locks it in place. So I'm going to show you how I put this thing together. Alright, so this is a DOF motor. You can ignore this 3D printed block here. This is just to hold it. So this is the DOF reality motor that you get with SFU attachment, and I've taken, just stripped down like the arm and everything, so you just have the motor and then this block here with the bearings in it, and then the screw drive at the end. So the first thing that we're going to need to do is put a bearing on the end. So this is the bearing that you need, and it is a it's 19 outside diameter by 7 width, and then inside diameter is 10 millimeters. So you're going to take that bearing and you're going to slip it over the shaft here. I had to file this down just to get some burrs and stuff off in order to fit it on, but it should go on nice and smoothly, just like that. And then you'll need to get a little clip for the end. I just happened to dig through my stuff and I found a little clip like this. You could certainly use an E-clip or a C-clip, but you just want to find something small that will fit in this groove right here and that's secure, that won't come off. So you pop in the clip, which is a little finicky. Just going to pause the video. Okay, got the clip in. Now the bearing can't come off, so that'll keep this screw drive from unscrewing all the way. And whatever you do, don't let it unscrew all the way and come completely off, because all the little balls and everything will fall out and you will be very, very, very sad. So you get your bearing on with the clip securely in the groove there. And then we're going to install the first piece of the 3D printed items. This is sort of the main actuator, and I printed this with PETG. I believe I used 5 walls and a pretty solid infill. It's not totally solid, but it's a dense infill. And on my Bamboo Lab P1P, it took about, I think, 6 hours to print, but it's pretty strong, and the way it's designed is for this application, all the force will be compressing inwards, so there's not going to be any pulling apart, and that's where the main weakness comes with 3D prints, is the adhesion between layers can get ripped apart and broken, but this will be all compressed. So you'll notice that there's like a little track right here, and this is where the sensor gear will ride to know where it is in space. And then we've got 4 holes here, and then 1 on each side that's going to bolt onto this. So we just simply, and then on the back side there's a hole here, you'll see, for the bearing. So the bearing fits in with just ever so slight amount of play, so it can slide up and down, but then it gives this shaft some side-to-side support in here. So this is going to go over like this, and then also this right here is going to rest inside and sit right on this. Get some light in here. It's going to sit right in these, right on that base in there. Pop that over, and then we're going to use 4 M5 by 12s. I'm going to put 4 of those in. And then you'll notice that they sit flush, or they are recessed down in, so they'll be able to slide inside the outer casing. And then on these 2 outside holes, we're going to put M6 bolts. And the only ones I have are too long right now, so if I try to thread them in, they bottom out before they go into the hole. So I probably need to get some M6 by, probably like M6 by maybe 8 would be good. So I'm going to leave them out for now, because I can always take it apart and put 2 more bolts in there. But that's the idea. That's sort of the inside there. And now we need to have the foot go on. So on the base you'll see there's 4 holes here. So we got 4 holes here, and then we're going to bolt on this end cap here. It's going to go like that, and then this cap will ride in this sort of plate that will just set on the floor, and then this will give it the articulation it needs. We can go ahead and bolt this on. Now what I did was, we're going to use M5 by anywhere between like a 16 and a 20 millimeter bolt. So something like this. And then I'm just going to go ahead and tap out these holes to make life easier for myself. I'll just do one on camera and then come back when they're all done. Kind of a pain in the butt, but it makes it a lot easier to thread the screws in. You don't have to tap it out, but that's what I'm doing. Now we'll see how it threads in. So it just goes in nice. So I'm just going to finish out the other 3. Okay, now that we got all these holes tapped out, we'll go ahead and put the cap on. Okay, so there's the bottom cap. And then we're going to go ahead and put this outside piece on. Now, if we take a look at the outside piece, this is going to slip over this. And here we've got an access hole for the sensor gear to go through. And it's going to go through this hole, and then the gear is going to ride in this track here. Got a couple little holes here for the gear mount, and then a cover that goes over it. And then at the top we have 4 holes to bolt into this bearing plate up there. And again, this is printed with PETG. I believe I did 5 walls, and seems pretty solid. Again, there's only going to be pressure, maybe a little bit of side to side, but there's not really a lot of force on this piece here. So again, I'm thinking that 3D printed parts will be okay for this. So let's go ahead and slide it on. We want to make sure that this track here is lined up with that axis. So this just slides over like that. And then I will note here too, there is a little sort of a lip there. And that's going to sit right on the bottom of that. So you can kind of, if I push it up, it bottoms out on that lip. And then we're going to use M6 screws, 4 of them all the way around, to secure that. Okay, so the screws that go in here are M6 by 16 millimeters. And there is 4 of them. So I'm just going to go ahead and get them all started, and then we'll progressively tighten them down. And then if you guys are interested, I can certainly share the STL files for these. I will say too that I have swapped out the Arduino boards in the DOF control boxes and installed a different sketch file. If you do this mod with the current DOF Reality software, you're not going to get the full throw out of these, but if you run the open source sm3.ino, I believe is the name of the file, then you will get the maximum throw. Actually, more than you'll need. You'll have to tweak it a little bit in the SMC settings. So this is definitely a major, DIY tinker, do at your own risk. Not for the faint of heart, I guess. So that is installed now, and kind of show you. So now if I rotate the motor, actuator goes out, and this will do 90 millimeters of travel total. And which is not super awesome, but this is more of a proof of concept than anything else. So 90 mil of travel, and I doubt this. I'm hoping the speed's going to be okay, but it's not going to be an AC servo motor actuator by any stretch of the imagination. Okay, the next step is the sensor. So here is the sensor cover, and then there's 3 parts to this. There's 2 gears, and then like a little mounting bracket. And we're going to go ahead and use the existing DOF Reality sensor. Don't mind this gear, this was for something else. So we need to take this sensor apart a little bit. So essentially what we're doing is we're just taking the bracket off the sensor. A couple little screws. Can leave one of the screws in, I believe. Yep. Okay, and now the sensor is going to go in this 3D printed bracket, and it's going to go, it doesn't really matter how it goes, but you just want to put it in, and then it's the same way that it bolts into this one. So it's just going to be the 2 screws. So I got the sensor mounted in the 3D printed bracket, and then we're going to put this gear on the sensor, and we're going to line up the set screw hole on the gear with the flat spot there. And I'm actually going to get the set screw in the gear first. And these set screws are the same set screws that come with the collar, the little aluminum collar that goes on these sensors. It's the set screw out of that. And you can use one or you can use two. There is two holes in this gear, but you really only need one. So I'm just going to get the set screw started. Back it out a little bit. And then line that set screw up with the flat spot. Be a little snug. So the hole in this gear is just a little snug, so I'm just going to take a drill bit. This is a 1/4 inch. Yeah, 1/4 inch drill bit. Well, I can adjust the file on this to get it just right, but every printer is a little bit different, so the tolerances could be slightly off. But I'm just going to take a 1/4 inch drill bit, just kind of ream this out a little bit. There we go. And then we're going to put this gear so that it's just flush with the end of that shaft right there. And we'll snug down the set screw. Doesn't need to be overly tight. And then the next gear is going to go, there's going to be a little screw that goes through this hole and into this hole, and then these gears are going to go like that. Alright, so you're going to want to use an M3 by 20 approximately. You know, it doesn't have to be exact, but it does have to be an M3. And then I'm going to use an M3 washer. I'm going to put the M3 washer over the screw like that, and then it's going to go in like this. Again, it might be a little snug, but what you can do is just thread it in. And then once you get it bottomed out, you can, spin it a little bit, kind of strip it out so it spins freely. And if it's a little bit tight, that's okay. I mean, this is pretty good right there. And we'll go ahead and install this screw into the block. And then you'll want to check your gear lash here, and you can move the sensor just ever so slightly by loosening up the two screws, but it should be pretty good. Once I get it close, I'm going to kind of wiggle this gear and get it down in there. Go ahead and snug this screw down. Obviously you don't want to over tighten it, otherwise the gear won't spin. So that's too tight, I can't turn it. So I'll back it off a little bit. Yeah, a little bit of wiggle there. And feels smooth. Little bit of gear lash there. That's okay. It's about perfect, just like that. Alright, now we're going to go ahead and put this on there. Okay, so for these screws here, you'll see this block here is a little bit recessed, but it's thicker than this side over here. So the thin side over here, you're going to want to use an M3 by 8. Get that one in. And then this larger block over here, you want to use an M3 by 12. Because you don't want them too long or they're going to go all the way through this and then start hitting that. So that's the length you want. And then we're going to go ahead and put the sensor these two little screws are going to line up with this hole and this hole. And then check to make sure the gear is in the track properly, which it is. And then just go ahead and tighten this down. Just a little bit of wiggle there. That one feels pretty good. And now you'll notice when the motor moves, it turns that gear, the first gear, which then turns the sensor gear. And that ratio is about right to locate the position. And now we will need to calibrate this before we put the cover back on. So you'll calibrate this just like you would calibrate any DOF motor using the SMC software. You may need to, if it's not working properly, you may need to take this plug apart and reverse the polarity here if it's running backwards. But that's how it works. And then get my sensor wire. But going back to the calibration, what you would want to do is thread this out so that you have 45 millimeters between this end here and this. 45 millimeters would be the halfway point because it's got 90 millimeters total of travel. So you find the halfway point at 45 millimeters, and then you'd loosen up this block here so that you can rotate the gear. And then using the SMC software, you would turn the sensor until you've lined up the little, I think it's the blue line. You'd line up the blue line so that it reads that it's centered, just like you'd calibrate any DOF system. Once it's centered, then tighten it down, you're good to go. This is locked at the center position, and this is at the center position. Then you plug in your motor, test it. If it isn't working right, if it's doing weird things, then your polarity is probably reversed, so flip your polarity. But that's basically it. So I'm going to go ahead and put the sensor wire on, and then I'll put the cover on. And on the cover, there's a little notch there for the wire to go in. And what I'd recommend doing is putting like a little zip tie around the wire and tightening it down so that it can't pull out anymore. I had to repair this wire, that's why it's like that. But now I will plug that in. And you just need to make sure you find a way for these wires to go in here so that they're not hitting the gear. If the wire wasn't all messed up, this is actually fits pretty nicely. I did it on the other one. But at any rate, the cover goes over it like that, and then you're going to want to use M3 by 8 millimeter screws, I think is what you want. Yeah, M3 by 8. And then you just bolt your cover on like that, and that's that. And then I'll show you the other locking bracket real quick. So here's the mounting bracket. The way it's designed right now, this should line up properly with 40 series aluminum profile. These are 40 millimeters on center here, and then you just use 1/4 20 bolts through here, and then that would pinch down and it'll lock right onto the motor. There's a little lip right here because this aluminum here is just ever so slightly larger in diameter than this black section of the motor. So when you put it on, you'd want to have that lip coming down so it slides over that, and then everything locks down. It's the only way I could think to mount this because this section here is not strong enough to be a mount. So it really kind of limited to this up here. So again, sort of a proof of concept. Anyway, hope you enjoyed the video. We'll see you in the next one.